what the car companies are doing are very interesting, and I think personally cars are one of the most important changes we're going to be made in our society as we move forward and what they do. We're going to start off talking about a column I just wrote in the New York Times, which seems to have pissed off the whole Midwest, in which I can't believe you, Kara Swisher. Anyway, believe it. About getting rid of a car. I don't want to own any other cars until I'm dead. And the hearse takes me away. But I want to talk about that and where cars are going and some other things where AI are within companies. Ken Washington from Ford, the CTO. Now, Ken, you're going to tell us how cool all this stuff is now. We talked about the disaster that it's coming. So let's talk a little bit about, I wrote a column last week, which did get like a crazy amount of commentary. Thousands and thousands of comments on the New York Times. People were for it. People were really, really for it. And what I did in the column is that I really don't want to own a car again. I think that I wrote a piece in the Wall Street Journal 25 years ago saying you will have mobile phones, you will not have landlines, you will not be wired, it will all be wireless. It was a very good prediction. And then I said, now you're never going to own a car, and it will be like as quaint as owning a horse. And I think that's the expression I used. I was trying to get a discussion going. I mean, obviously, you want to talk about where this is going, but I do truly believe that we're on the cusp of this because of self-driving and AI and the stuff that are going to go into transportation. So let's talk a little bit about cars first, and then we'll get into the other things that companies like Ford and others are doing, or where AI does benefit a company. So let's talk about where we are with autonomous vehicles right now and where AI fits in.
Well, first, I just want to say I think you definitely got people's attention with the article.
Yeah.
I think the response was a reflection of the fact that people love cars.
Yeah.
And some people hate cars.
Right.
But everyone needs to move around. Mm-hmm. And what autonomous vehicles has done for us is given us the potential and the promise of a new way of moving around, and a new way of creating mobility, and a new way of solving real pain points in cities. Yeah. And what I loved about your article was it really shined a light on the fact that in urban centers where you really need a different model, that now this new model is beginning to emerge.
Right. I wasn't talking about car ownership. I was talking about I was talking about car ownership, not car driving in. I will continue to drive and move in mobile vehicles, depending on, but it was the car ownership, and it's an idea of ownership just the way we owned entertainment before. Now we really don't. Just the way we own records, we own this. It's the same concept, is that this is one that's moving in, and especially in urban areas where I think 90% of the population is going to be in a megapolis over the next 25 years, like 90%. So those other 10% can have their cars. It's fine. But it's just what happens with our population. So talk about where we are and how AI fits into the idea of where we are with autonomous. Let's start with autonomous vehicles. And these are, we're right in several stages, right? 3, 4, 5. We're in 3 now, which is...
Well, let me just clarify that.
Okay.
So it's a term that's often really misused and misunderstood. So when you're talking about autonomous vehicles, particularly in urban cities where you predict 90% of people are going to live, what you really have to think about is an autonomous vehicle that can truly sense the environment completely and can truly take the human out of the loop.
Right.
And so that's a level 4 autonomous vehicle. And even that level 4 autonomous vehicle that can operate in this urban environment, it's going to have some boundaries around it. So it's going to have the ability to operate in a city that it's seen before, so it has to have been mapped. There are going to be weather restrictions on it, at least with today's technology. And there are going to be speed restrictions because the sensors aren't perfect. And hopefully no one in this room believes that the AI part of the problem has been completely solved. And you can't even review resumes with AI and not screw it up. So getting the AI right in a vehicle is really hard. And it involves a lot of testing and a lot of validation, a lot of data gathering. But most importantly, the AI that we put into our autonomous vehicles is not just machine learning. You don't just throw a bunch of data and teach a deep neural network how to drive. You build a lot of sophisticated algorithms around that machine learning, and then you also do a lot of complex integration in with the vehicle itself.
Right. So talk about the challenges. What are the challenges faced right now by getting to that level of, I guess it's full autonomy. There's all kinds of different ways people discuss it, but the full autonomy where you get it, you call something, it comes to you efficiently, and then you take it somewhere.
So we like to use the term self-driving.
Right, self-driving.
For the full autonomous vehicle that you would use in an urban city.
This is without a driver in the front.
Without a driver in the front. And the state that we're in today is that it's still a development activity.
Right.
And so we still use safety drivers
Who
who sit in the driver's seat.
Because from what in my experience, I've been in a lot of these cars.
Yep.
The original Google ones that were before Waymo, I guess, were people who are sitting in a car that's been tricked up, a car that's not built specifically to be autonomous, which means they took a regular car and stuck stuff all over it, which everybody
Pretty much everyone does
everyone
that today.
does that today.
Pretty much
right.
everyone does that
Then
today.
they had their clown car, which had no, which I drove and I tried to run over the head of Waymo, but it didn't work. It had no steering wheel. It had no pedals. It was like a Disney ride, essentially. Like you got in, and I just was texting and drinking the whole time. And no, I wasn't. No, but it was just. It felt like a Disney. Like I was on a ride at Disney
Sure.
World, and between that there's something else going on. So talk about where we are in that.
So where we are right now, and the reason you don't see those kind of cars on the road today is that I think Google and a lot of other tech companies, many of them out of Silicon Valley, have realized just how hard it is to make the car part.
Right.
And so where we are right now is, we have basically a software company that it was a startup. It was founded by, one of the ex-Google leads, Brian Zaleski, and co-founded by Pete Rander from Uber. They joined forces and created a company, and Ford invested in that company. We invested $1 billion in that company. And they've grown that company to a little north of 300 people. And they're working shoulder to shoulder with engineers from Ford to develop the vehicle part, the software part, and all the really messy stuff that has to happen in between to connect them together. And then we're working with cities, and that's a really critical part. You can't just put a vehicle together and just show up and expect
Right.
it to actually do something that's going to be a good experience. You need to work with cities to understand how do vehicles work in the city. What are the behavioral patterns of citizens in this city? What are the pain points of people that want to move around? What are the congestion patterns like? And then you interact with the people in the city so that you understand what the human needs are. And then we're working on taking all of that information and folding it into creating a business that will work with a self-driving car.
Right.
So that's where we are today, and we're in the process of testing. And we're testing today in 5 cities, preparing for deploying.
What are the cities you're in?
The 5 cities are Miami, Washington, Dearborn, Pittsburgh, and we just started testing in California.
And why did you pick these cities?
So Miami was our first pick because of the it's a fairly large city, and it had a fairly diverse population. That was really important to us. We wanted to work with a city that had a really favorable political climate, while also a really favorable, really had a need, right? And so we started talking with the city, and that we realized that we actually could have a good relationship with the city, and they had a real need for us to solve a pain point in the city.
Which is congestion.
And it's congestion, and there were a lot of underserved communities that didn't even
get-
own a car,
Right.
and had no way to get to work, and
Right.
and it was a multilingual city, and so we knew that you had to solve the diversity challenge and meet that challenge to be effective at scale. So it was a really ideal city for us, and also it's a place that has really good weather. And
Right.
we didn't want to take on too big of a problem at first, because look, level 4 autonomous vehicle, a self-driving car that's going to operate without a person behind the steering wheel, and you're going to put your loved ones in this vehicle, and you're going to trust that this vehicle is going to take them where they want to go.
Right.
It's a really hard problem.
Yeah, but I've
And
driven with my mother,
so-
so I've already passed that test. I take a self-driving vehicle any day of the week, and twice on Sunday. So talk about the AI elements, because people don't realize it's both making the car.
Yep.
And putting the AI elements. AI is pulling in so much data, pulling in and understanding it, and then there's the sensors part of it, and the radar. There's several different pieces of it. The car making is a really important part that people, I think, don't realize. And there's all kinds of different kinds of cars being made now. But I remember being struck by someone at Uber many years ago telling me, "Oh, this self-driving thing is going to be easy. Car making is trivial." And I was like, "You're an idiot." Like, for so many other reasons, but.
Yeah.
This one is really stupid. This is a particularly stupid thing to say. So talk about that. Like, how do you integrate these physical objects, a car, which could be made of anything going forward, and the AI together? Like, what is the challenge of that?
Well, there are many layers to that challenge. So the first one is that I'll talk about is the challenge of getting the software and to integrate into the hardware, because there are many ways you could do that. And so we've learned through experience that the best way to do that is to design the hardware to have an abstraction layer. That is, don't design the software in the middle of the vehicle hardware. Make it so that the software team can just work on the software, and then the hardware team can define well-defined interfaces so that the software can then integrate in with the vehicle. So that's one of the first challenges. But the actual design of the vehicle itself is not trivial, because a self-driving car is going to have a different interaction experience with the human that's going to use the vehicle. When you ride in a self-driving vehicle, you're going to have a different way of approaching the vehicle. You're going to have to hail the vehicle. It's going to have to know that, oh, that's you that just hail the vehicle, and how do I know that it's not the person that's walking behind you and it's going to hop in the car instead? So there are all kinds of challenges associated with having a way to interact with the person that's going to get in and take the ride.
Yeah.
And so there's design challenges. And one of the things that we've been thinking about and actually implementing it with AI is using AI inside of our engineering team to help us do the design of the vehicle itself, so that we can optimize the solution to some of these challenges.
Meaning what?
So let me give you an example. Right. So one of the things that we've begun to work with in the AI space is with 3D printing and designing differently. When you can 3D print certain parts and certain components on a vehicle, you can design the part to look any way you want, right? Because you can print things that you couldn't forge or you couldn't make with some other method. So there are AI-enabled engineering tools that will design the part in the same way that nature would. It's called generative design. And so we're working with some of the companies that are on the forefront of this technology to do generative design of some parts that we may end up putting on our both autonomous and our non-autonomous vehicles.
Right, meaning designing for how would that, it knows what people want?
So you give it the parameters,
right,
and you tell it what engineering constraints it has to meet. It has to be so strong, it has to have this property, has to have this size, and then the AI will actually go in and say, well, it needs to have material here and here and here, but it doesn't need to have it here, so it can lightweight the vehicle, and it can ensure that it's going to have the right properties and the right strength, and then you can send that to a 3D printer, and it will make the part.
Make that particular part.
Make that particular part.
It could also be used with consumer preferences too, correct?
Absolutely. You could use it for customizing parts, because imagine that you're the owner of an autonomous vehicle fleet, and you're entering into a ride service. What if you wanted to make your autonomous vehicles customized for your service? You could actually design a customized part that would have an emblem with your company name on it, and you print that part and put it onto the vehicle. It's a great example of using AI together with a new technology like 3D printing, together with the real opportunity to provide a new service to society. So a lot of technologies clashing together to create new opportunities.
So when you think about the other part of the AI, it's also mapping. It's also understanding cities and geographies. We're having code in Arizona, and we want to take people to this one area, but they don't have it mapped at all, like in autonomous vehicles. And so they can't really do any. There's also, there's no sensors in the roads. In some places, they're putting sensors in roads to be able to do that. There's all kinds of ways to do that. But they didn't. They hadn't had enough AI technology deployed there to understand a place. So could you talk to people about what you have to do? You've got to basically map the whole world again, and then it's also a world that's also changing all the time.
Yeah, so this is a really important point. And it's really important to know that a self-driving car has to operate in a region that you have fully mapped. And this is not your navigation map, the kind of map that you would use on your cell phone and you pull out and you do a Google map or an Apple map. This is a map that is developed by driving the space with an autonomous vehicle that's got light detection and ranging sensors on it, or LiDAR for short. It's actually shooting light beams out in 3 dimensions off of the roof of the vehicle, if that's where you've got your LiDARs mounted, and it's receiving the light back, and it's then capturing these points and and creating a 3D image of what the world looks like. And then the vehicle uses that static image of what the world looks like, and it does some fancy footwork to take off the parked cars and things that could move, because it wants to know what won't move. And so when the car is then self-driving in that region, the LiDARs operate again, and then they make a comparison of what was there statically and what do I see now. And if something is there that wasn't there when you were mapping it, that means it could move. It could be a kid on a bike. It could be, another person. It could be a pedestrian. It could be another car. It could be a dog. And so the task of, first of all, knowing that these are things that you need to know about, you need to predict them, you need to know their trajectory. If you don't have that prior map, you're relying on, in real time, detecting everything that might happen. And that's just too hard of a problem. That's why these vehicles that don't have LiDAR, that don't have advanced radar, that haven't captured a 3D map are not self-driving vehicles. Let me just really emphasize that. They're consumer vehicles with really good driver assist technology. So some West Coast companies that sell really great electric vehicles, I won't name them, they're really great driver assist technology vehicles, but they're not self-driving vehicles, right? Okay. Because in fact, you can prove that because you can Google and find out that they've been tricked and they do all kinds of crazy things because you put things in the environment that they don't understand. Or when the line markings are covered with dirt or gravel or snow, they don't work. And, so I could go on and on, but the point is, you gotta have a prior map.
Buy a Ford,
I got it. Advanced. Okay. No, that's not the point. No, seriously, that's not the point. The point is, you gotta be clear about the fact that self-driving involves a lot of complex technology, and you gotta approach the problem with that kind of seriousness. Right. And Ford's not the only company doing it that way, but we are doing it that way.
Though, let me be fair, y'all wouldn't have been in this if they hadn't started it. Like, let's speak. This
no, I gotta push back. I gotta fix that. Okay,
so, I don't recall you saying it. Not you, Ken.
Ford was the only automaker participating in the first DARPA challenge. We just didn't go in with our name.
Explain what DARPA challenge is.
The DARPA challenge is a Department of Defense. DARPA stands for the Defense Agency Research Projects Agency, and they every year put out a big, difficult challenge out to the technical community, and it's usually something that they think is too hard to solve. And they pour a bunch of money on it, and they say, what teams can come in here and give us a solution to this problem? And usually they're so hard that nobody solves the problem. But you learn a ton. And sometimes, in the case of self-driving cars, it sparks an entire industry. And so the very first DARPA challenge was they put out the challenge of building a self-driving car. Of course, nobody knew how to do that at the time. And so Ford was the only automaker that participated in that first challenge. In fact, we bought the first Velodyne LiDAR and bolted it on the top of an F-250. And of course, we didn't succeed in the trial, and nobody else did either, but we learned a lot, and that launched the Ford Autonomous Vehicle project.
So I'm not going to argue between who. One of them's going to. You're all going to make them essentially.
Yes,
this is. You're all going to make them and things like that. What is the? I want to get back to AI and the bigger question of where AI fits into it. But what would you say if you had to estimate? And I know you probably hate this question. When will you see a shift completely and from human driving? Because I think we can all agree humans are the problem here. Humans driving is the issue. And one person told me, very interesting, and I thought it was really smart, really stuck with me, was when an autonomous vehicle has an accident or has a problem, all the others learn through AI and other technologies. When a human makes a problem, they make it again, like I did the other day when I just hit a car. So I've done that many times. And so I talk about that. Like, when do you imagine it rolling out?
I don't think it's going to be a step function. It's going to be a gradual deployment.
Like horses to cars.
Yeah, it's going to be kind of like that. And it's going to be kind of like, when the internet rolled out, everybody didn't just suddenly jump on the internet, right? When cell phones came out, you had people walking around with bricks on their shoulder, and every once in a while, somebody would show up with one. And I think it's going to be kind of like that. You're going to see, some of the easy cities have programs, like Miami and Washington in the case of Ford, and our competitors have picked their cities. And so you're going to see self-driving cars roll out in fleet deployments for both people movement and package delivery in those easy urban environments that are easy to work with.
When?
And you're going to start seeing that in 2021.
2021. This is
2020, and
delivery.
you may see some early ones in 2020.
Right.
But we believe that taking the time to work with the cities to design the business right, so that when you show up, you make it better instead of making it worse. Because,
Right.
I mean, look, this is an optimization problem. If you just put a bunch of autonomous vehicles in a city without designing it to make life better in that city, you're going to have an analogous problem to what happened when Ubers first started showing up. People hated them because they were like, camping out on the corners, and it made congestion worse, and it created additional pollution. And so we're going to go into these cities and work to design the solution so it makes the experience better.
Right.
And so we're going to take 2020 to finish that process and then go in 2021. I think that's going to be the beginning of this slow deployment.
So does that make Ford and your competitors, the others, are you car companies anymore, or are you data companies, AI companies? Because it really is, I do understand the car itself is interesting, but these will be fleets of cars, and possibly you will be running the fleets and not people owning
right.
them. That it won't be that everyone doesn't have an autonomous vehicle. They will just be in fleets, and you will rent them, or there'll be something like that.
Yeah, I think that's right. We think of ourselves as a mobility company,
Right.
which includes being both a car maker and also a company that has an AI core competency. We have to have an AI core competency, not only because you need AI in order to pull off this self-driving task, but in parallel to slowly and gradually rolling out fully self-driving vehicles to a small set of cities, we're going to keep putting more and more AI into the vehicles that people are buying and leasing and renting and using.
And why is that to stop becoming assisted driving?
Well, because humans aren't very good at driving.
Yeah.
I mean, most people are worse drivers than they think they are, and
I'm a real bad driver.
I
know
I
it.
think a lot of people are.
My children know it.
You're-
They're here.
You're not alone. I mean, we're all flawed humans when it comes to driving, and because it's actually not that easy to be a great driver.
No,
because
I'm
you
in a constant rage. But go ahead. Sorry, but go ahead. So you have to have AI in the cars. What does that look like?
You need to have assistance, and we know that we can provide more and more driver assistance because the technology is getting cheaper, sensors are getting smaller, compute is getting faster, memory is getting more.
So how does that look
ubiquitous.
at,
So-
talk about sort of in 5, 10, 20 years? Like right now I've got a car that beeps at me going backwards, and I can see the backwards. It beeps at me when I don't have, it just beeps at me when I have a belt on.
Yeah.
It's not very assistant. It's an irritating person, really.
I'm actually glad you said that. And the reason I'm glad you said that is the reason these cars are beeping at you and doing all that stuff is we've done a terrible job of designing the human experience in the vehicle.
Yeah.
And we've learned that we've got to, take a step back and start thinking about that
You're
differently.
right. If
Starting
it
with
spoke to me and said, Kara, you don't want to die today, put that on. That would be nice.
And everyone's gonna want a personalized experience, right?
Right.
So think about when you first bought, how many of you have an Alexa device or some kind of smart home device? If you have a smart home device, you start to interact with it, and it gets to kind of know you, and you can actually train your voice on it. And well, why shouldn't your car have that same kind of interaction with you? So we're thinking about building AI into our vehicles so that it can be personalized, so that it can be a better experience for you, so that when you get into your vehicle, it's your sort of oasis of it's yours, right? And even if you don't own it, if you get into a vehicle that's shared, there's no reason why that shared vehicle can't know who you are too, because you got your smartphone with you. It knows you got in. It's got all the data in the cloud. And so it should be able to say, oh, hey, Kara, I see you're going on a shared ride, or you're on a Lyft or an Uber ride. And, it knows that you don't, like this kind of music, you like this kind of music, and you like the temperature set to 72 or 71. And so AI can totally change how we think about delivering an experience that's curated for you.
All right, so talk 5 years out, 10 years out. What could it be, before we get to fully autonomous, what could that be in it? You're driving a car. It has your temperature. You don't have to figure out how to the hours I've spent trying to get the car to talk to the phone to play the music is insane. Like, it does that without a problem, right? Never that is never going to happen. But what does it do? What are the other things it does? Puts your seatbelt on properly, does the seat properly, right? That kind of.
I think we should think more broadly about how the future smart AI-enabled vehicle will interact with the rest of the smart world around us.
Right.
I love tinkering with technology in my home.
Mm-hmm.
So my home has all these smart sensors on it.
Mm-hmm.
Well, in 5 years, your car that's got AI in it's going to interact with your home that's got
Right.
AI in it. And so when you pull up to your home, the garage door will open, and when you pull in, the garage lights ought to come on, and should unlock the door, but only if you wanted to. You could say, "Don't unlock the door." Unlock the door. So it should just be seamless and frictionless, because you've got this rolling computer that's got AI in it with all these sensors on it. Oh, and another thing is, why can't this vehicle serve you in other ways if it's in your life? Let's say it could be a sentinel for you. It could turn on the lights and warn you if somebody comes around your home. It could.
Wasn't that the plot of Christine? That movie? That ended badly for the people.
Well, look, we can take cues from sci-fi in lots
right.
of
Okay.
lots of ways,
So it's
right?
your sentinel sits out there, and when someone comes along, like a dog, like what?
Well, so this is all part of the
Yeah.
iteratively improving
So
part of
it
AI.
uses AI to
So-
take sensors from around. It's already got sensors, so why not let it do other things?
Exactly. And imagine at a work site, if you're driving a truck or a commercial vehicle, how it could be an assistant to you. So look, I think there are lots of opportunities here to stitch AI into a vehicle. But one other thing is, we're also using AI to help us make the vehicles higher quality. An example is out of our Silicon Valley lab, and by the way, I don't know if your audience knows that we have a presence in Silicon Valley, and it's been a huge benefit to us because we've met over 1,000 startups, and of those 1,000 startups, one that we met is an AI company that actually was using AI to detect flaws for a totally another industry, and we were talking to them and says, you know what, one of the really hard problems we have is finding flaws in the quality of wrinkles on seats when we make them. I mean, it sounds really silly, but it turns out it's a hard problem.
Wrinkles on seats.
Yes, it's
Okay.
actually a hard problem. And we
I
actually
hate a
had
wrinkly seat on
we
a car.
had people. We literally
Yeah.
had people looking at seats, going, "Yep, that one's wrinkled. Send it back. Nope, that one's not." Right.
Wow.
And so now we have that company deploying AI to do quality inspection, improving the quality of our seat inspection and manufacturing process using image recognition and AI.
So what? It takes pictures of the seats and then it knows.
Takes
a
pictures
wrinkly
of the
seat.
seats, and it learns and it iterates and it gets better and smarter, and it makes us.
So it
makes us-
rejects this, like.
Yep.
It just says no, like.
No. Yes. No.
Yes. Right. Yeah.
It's a great example of the use of image recognition
Right.
to improve the manufacturing process. And there are many other examples. The point is that we're embedding AI as a core competence to enable us to make cars better, but to make the experience of owning a car better, and also driving a car more safely and more smartly.
So
in
talk about
addition
that part.
to self-driving.
Talk about that, driving it safely, and what could it do?
So earlier, I was downtown talking with another group about the fact that we still have a large number of fatalities in the U.S. and globally with automobiles on the road, and the vast majority of those fatalities are driven by human error. In fact, the fatality rate in the U.S. went up in the last few years, and that's largely driven by both the complexity of traffic on the road and by distracted driving.
Right.
And so if you can use AI to detect when a person is distracted and they're driving by having internal image recognition or other bio cues, you could save lives. And so we're working on
And what would it
interior.
do? Shut down the phone or whack it out of your hand or what?
Well, hopefully nothing quite that intrusive, but you could
I think it's a
certainly
brilliant idea, but go ahead. You can borrow it.
you could certainly slow their speed down, or you could
Oh.
alert them, or you could
Report them
vibrate
to the
the
authorities.
That's a little more intrusive.
I know. I'm
going to
get to the creepy stuff in a minute, but go ahead. So go ahead. So safety. So slowing people down if they're texting. And
that's right. So you can make the experience safer. We're also working on the next step in driver assistance technology, because it's going to be a gradual rollout before you have fully autonomous vehicles. Oh, and by the way, fully autonomous vehicles are not going to be the kind of technology you're going to go out to your dealer or even to a showroom and buy a personally owned autonomous vehicle anytime soon. They're extremely expensive because of the sensor suite and the kind of compute that's integrated into the vehicle. But the kind of technology we can increasingly put on the vehicle can give you really great driver assist technology experiences, because we can now put the kind of sensors that similar to the ones that we put on our self-driving cars, just without a prior map and without LiDAR. Radar is getting really good. Camera technology is getting extremely good. And then the AI software is getting very good. So we can do more than just lane keeping. You can do lane centering, lane following, the kind of thing that's been available for, from that West Coast battery electric company for a while. But that's now rolling out very at scale
in human-driven cars.
In human-driven cars.
So when you think about all this stuff, some of it sounds great, some of it sounds extraordinarily creepy.
Yes.
Talk about that, and because given the previous stuff about where these things go wrong, like some of this sounds great, like some of the stuff they talked about sound great. Weather, climate, things like that. Yeah. What are the worries you have as the CTO? Like it could do a lot of things that aren't so good.
Yeah, that's right, and that's why you have to be very intentional about how you treat data and how you treat both the collection and the diversity of data, and the care of that data.
Right, like the thing you talked about, the texting. That could go right to the insurance company. That could go right to wherever, the police.
Exactly right.
Things like that.
Exactly right. So it starts with building the trust of the owner to feel good enough about how you're going to care for their data that they're willing to give you access to it. And our experience is that trust and that willingness will happen when you can offer something in exchange for that's of value. And then when you don't break that trust. And so trust is really hard to gain, and it's really easy to lose. And so we're being very intentional about how we're caring for the data that we have
so that
the honor
speeds
of managing.
People going, whether they're speeding or not, where they're going, what they're doing in the car,
all of that,
what they might be playing on the, because I was just thinking the other day, the reason I was laughing a second ago is I was driving in San Francisco, of course, and someone was watching one of the movies, and I looked over. It was a porn movie, and I was like, "Whoa, that's too much." I was like, "Wow."
TMI there.
I was like, "Whoa, that's a porn movie over there." And I thought. Then I went San Francisco. It's fine. But it was really interesting, and I thought, well, I feel intrusive, and yet I'm appalled by these people. And at the same, it was like it went on and on, but it was like they would know that someone was doing that in the car, what they were at. Your car is your oasis, so why should there be sensors and AI telling you what to do and making decisions for you in these cars?
And your example is a good example that you can choose what kind of activity you want to do in your own car because it's your car.
Right.
And if you've given us access to that data because we're going to offer you some service, we have the responsibility to not share that with other people or use it for any other purpose other than what we've contracted to do with.
Well, I understand it might come as a surprise, but some of these companies are actually sharing data you didn't intend for them to share.
I understand that, and that's why it's really important to us that when we say, our aspiration is to be the most trusted company, that's what we mean, that we're not going to share.
Talk what you think about the ethics around AI, and that it seems to me that any data that they can suck up, they do, and any way they can chop it up and use it is open season. It seems like that. That's the ethos, is that this is going to be good, and if you just sit quietly, you'll be able to benefit from this. How do you deal with, you have an office in Silicon Valley. How do you look at the broader tech industry, which is moving into your businesses? Uber is, Google is, Apple sort of is, but isn't anymore. I can't tell. They're all moving. Amazon probably is lurking somewhere around,
Yeah. Well, they definitely are.
They're lurkers, yeah. Go ahead.
They definitely are.
Yeah.
There's no doubt about that. I can't speak for how they manage and treat their data, but we're very careful about how we treat the data that we have access
Well,
to.
yeah, but you have to work with them. So how do you
We
look
do.
about that going forward? Because this is not going to be just a solution for Ford. It's going to be with Google, with Apple, with the Amazon delivery. You're not going to get in the delivery business, my guess, for example. Maybe.
Yeah. So our self-driving vehicle may be a self-driving technology for a fleet delivery service. So we might be in that business from that point of view.
Yeah.
And we'll have to work with them and agree that if you're going to work with us, we have to agree how you're going to treat the data of our customers. Because if it's a customer that's in our car, they're our customer. And we'll have to have an arrangement so that it's you color inside the lines.
What do you think about these issues around the ethics of AI then? Who decides what gets done? Because this is being done by your company, it's being done by Google, it's being done, everyone's making these decisions that are private companies and in the interests of shareholders. You want to, like you said, you want to make a business of it.
Right. So, it's a big question. And, I don't think any one company has the answer to that, which is why we're working with, coalitions of companies. I think the whole industry, the whole mobility industry, the tech companies, the tier one supply base, automakers, we've all got to have much more conversation about that topic. It's a hard topic. And I'm not going to sit here and, try to make up an answer because I don't have an answer. Because we're charting into uncharted territory. No one's built a robocar before, and no one has deployed an autonomous vehicle at scale, or at any scale, in a city where people are riding it and they have access to data and watching movies in the back of the car. This is new stuff. And so we've got to have the conversations about, well, where are the boundaries? What's fair game and what's not? And how do I exchange the access to your data for something that you're going to say it's worth it? And I think we're going to have to go slowly, try some things out, test it out, and see, hey, how did that feel? And we're going to capture, and we're going to have to measure that, and then build on that and learn from it.
All right, and then we're questions from the audience. What is the scariest thing that you've seen with the AI that you've been, oh, wait a minute, that's not good? And what's the totally weirdest, and what's the coolest?
So I think, let me start with the coolest.
Okay.
And actually the coolest might be the scariest too.
Okay.
So we're doing some research with something called GANs, G-A-N, stands for Generative Artificial Networks.
It's scary, just the name.
Yeah, even the name is scary.
Yeah.
But this is pretty freaky stuff. So using this technology, you can actually take a neural network, an AI algorithm, and you can throw a bunch of data and teach it what Kara Swisher looks like. And after it learns what Kara Swisher looks like, it could then project your image onto, pick any random person who's roughly about the same size as you. And then that person can start talking and can deliver a speech, and it will look and sound just like Kara Swisher. And so it's got...
Oh, generate onto this guy?
Yeah,
right here?
absolutely. This guy, you could be talking and...
I know. That was the plot of Captain Marvel, but okay.
And using
All
this technology, you could create like a digital movie that made it look like you were saying something that you weren't.
Well, yeah, that's deep fakes too. Yeah.
Right.
Yeah.
And now here's the practical application of it, and this is why I think
All
it's
right,
cool.
where's the cool part?
Here's the cool part. The cool
horrible.
part is using this technology, you can take scenarios of environments, say like city streets, and so let's say you want to do a bunch of autonomous vehicle testing in the city of Miami, like we really do, and we go and we take a bunch of video of cars running in a bunch of scenarios in the streets of Miami, and we take the video of cars and we do it in daylight on a nice sunny good weather day, and we test vehicles against those images and those videos. Using this technique, I can now project a rainy day on that same scenario. I can project a snowy day. I can do a foggy day. I can put new people in that environment. I can change the conditions of the roads.
I think that's the
and so on and
holodeck
so
from
forth.
Star Trek.
It's kind of like the holodeck, exactly.
Right,
It's
right.
super cool technology, and it's a way to amplify the ability to do simulation testing, which is why we're doing research in
Because
that
it's got,
space.
it has to have so many factors in it.
You can't just test in sunny weather. You have to
Right.
test in all kind. But who wants to go out and test in the snow and the rain, right? So,
Yeah, who wants to do that?
right. So,
Because it would be safer. And what's the weirdest?
wow. So, I don't know if it's the weirdest, but something that I think is really promising is the AI that we've been talking about is taking AI and putting it in the car. But you don't have to stop there. You know, the AI and the sensors and the intelligence that goes into a self-driving car, well, it can be out in the world too, right? So, you know, why just put LiDAR on the top of the roof of cars? What if you stuck LiDARs in every intersection that you wanted to drive in, and all of a sudden every car could kind of be a self-driving car if you could get the data that the intersections determine into that car. So that's something that we're doing some sort of early phase research on is how might you instrument the world so that self-driving could be democratized. We think that's pretty cool, and it's kind of weird because it kind of flips the self-driving problem on its ear, and it says, well, you don't have to just build a bunch of robo cars. You could build sort of robo cities too,
Right.
And that could make life better even if you're not in a smart car.
Right, which would create that these cars would react to
Yes,
everything, but they'd have things in the cars that would react to it, right?
absolutely.
Right.
Yeah. They'd be able to say, oh, I just got this signal. I'm supposed to stop now, or I can turn left, or I have to take this path, not that path. Oh, and by the way, if you've got an array of this kind of sensors in a city, and you've got vehicles that have been equipped to react to that, now you can begin to think about how would you create a society where congestion begins to decrease. Because congestion is not going to get any better if you just put a bunch of robocars in a city. You know, you've got to figure out how do you make them synchronize better? How do they behave differently? How do they optimize? If I drop this person off, what's the next person I should pick up? And should I pick up that person 8 blocks away because I'm going to get a better fare? Or should I let somebody else pick that person up because that's going to reduce congestion? That's an optimization problem. Turns out it's a really hard optimization problem because you've got lots of factors, you've got lots of pieces, you've got lots of potential paths, and there's like no hope of solving that optimization problem if you try to put all the potential states in a traditional computer and then crunch the numbers. It just won't work. There are too many variables, there are too many scenarios. But you know what will work? A quantum computer could solve that problem. Seriously.
Yeah.
And so we're talking to quantum computer companies about factoring that problem in quantum space. So this is the perfect application of quantum computers. So a lot of people say quantum computers, they're just science projects. Today they're science projects, but they're really good at solving complex optimization problems.
Right.
And we're working on trying to factor that into that space so that we can apply a quantum computer to actually solve congestion. It's a little far out there, but hey, you asked for the weirdest thing.
That's a good weird one.
That's a weird one.
I thought you were going to say hovercraft, which is what Larry Page always says. But hovercrafts.
Well, I knew that he said that. That's why I didn't say it.
Yeah, okay, good. Are you working on hovercrafts? Whatever.
We're studying them, yes.
Why?
It's my job to look over the horizon at all the weird, freaky stuff.
Your
that might
thoughts on a
happen one
hovercraft?
day.
No, they're really studying. They're really making hovercrafts. And
Look, I
Silicon
mean,
Valley.
it's really not that wacky, right? Because batteries have gotten lighter. The fact that you can fly drones now, it's just a big drone. And carbon fiber has gotten light enough and strong enough that you can actually make them so that they can fly for several hours. And if you could actually fly one of these things and put 3 or 4 people in it and go from San Jose to San Francisco in 15 minutes, the economics actually works out so that it's cheaper than
Yep.
taking an Uber.
Yeah. And
So-
also vertical lift and takeoff vehicles.
Exactly, and it's quiet.
Yeah.
Quiet. I mean, the reason people don't do helicopters is because they're noisy, right? And so they're noisy, and they don't really play nice with airspace. So
Yeah.
so if you've got something that's quiet and it's electric and it can vertically take off from basically any of these underutilized regional airports, and it can fly from San Jose to San Francisco, and you can do the economics and make it work, I think people would pay for it. So that's why we're studying it.
All right. Anything else weird you're doing? Sounds weird enough.
Well, so that's an example of one mode of many potential modes of transportation. So we're looking at a lot of different modes of transportation. We bought a scooter company.
Yeah.
Most people don't know that.
Which one do you have?
We bought Spin,
Ah,
and we
it
like
just showed
Spin.
up here.
Yeah, we like Spin a lot
Yeah.
because they kind of took the same philosophy that we did for taking vehicles into a city. They took their scooters into the city, but only after they talked to the city, which we thought was pretty polite. And so Spin and Ford really have a common culture, and
Yeah.
we're working with them to figure out how does they help us solve the last mile problem.
Do you like the scooters? I love the scooters.
I love them. I
I'm a big
absolutely love them.
scooter.
They're cool.
They
Yeah.
caught me in a video. My boss did, actually, and put it up on the internets. And I wasn't wearing a helmet. I usually do wear a helmet.
Oh,
when I do it.
not good.
Most people do not wear helmets.
Yeah, well, wear a
Yeah.
helmet. We
I
want
like a
you around,
scooter.
wear a helmet.
All right, questions from the audience. There's lots of them here. Start right here, and then we'll go.
Hi. So you mentioned a specific West Coast company that was in the news recently for some.
He meant
lane changes
Tesla.
that-
I meant
yeah,
Tesla.
yeah, yeah.
Come on.
Right. So
I was
Tesla's,
just being funny. It was
right,
Tesla.
right. So Teslas have been
Elon's
changing
not going to
lanes
find it
without
funny
meaning to,
today
right?
on Twitter, but go ahead.
So people realize you can put stickers on the ground, make them change lanes when they shouldn't, right?
Right.
But that kind of problem isn't specific to their camera feed stuff, right? Like you can do that with LiDAR. That's more of like an AI problem where you can trick the systems by constructed edge cases that cause them to behave outside of spec, right? So, and this is a problem that you see also in like Internet of Things devices where suddenly you have a whole lot of attack spaces that you can attack them from, and they're really only as secure as like the weakest link in the network. So when you're designing a car that uses AI and that networks with the home, for example, how do you deal with that?
So you deal with that by not having a single line of defense. And so the tricking the car by putting stickers on the road and doing other things can trick a path planning algorithm if that path planning algorithm has been trained on existing images that didn't have the stickers. And it also can be tricked if you're using cameras that are looking for cues on the road. It can't be tricked if you're looking for cameras that have looking for cues on the road, if you're looking for a comparison of the world relative to a prior map, and if you're looking for signals from radar, and if you're looking for geolocation information from a GPS, and if you're looking from localizing the vehicle based on bounces off of other objects in 3D space. That's exactly the approach we take. We don't rely on any one or two or three set of signals. We do multiple lines of defense. It's never going to be perfect, but it's going to be a lot better than just saying, oh, I'm looking at lines on the road, or oh, I'm just going to rely on either radar or camera. You got to have at least three, and in some cases, four approaches.
Okay, another question? All right, Jill. Make sure. Someone over here. Put up your
Hi,
hands.
Miriam Vogel, Executive Director of Equal AI. And I'd love to build on the last conversation. It sounds like you've given a lot of thought into the variations and the complexities. And I'm curious what you've done to make sure that your training sets are mindful of drivers and passengers and pedestrians that are not the prototypical coder.
Yeah, so a couple things. So first, our algorithms for our self-driving system that Argo is building are not all machine learning based. It's a mix of machine learning that's trained by diverse data sets in the real world and in simulation space, and rule-based algorithms that are based on rules of the road, like, you know, this is a stop sign, this is a yield sign, you're supposed to turn, do a yield it left, yield it right. And so it's a combination of a deterministic and a learning based machine learning algorithm. As far as the diversity of the data set, it all comes down to having test data from multiple cities. And we're currently testing, as I said earlier, in 5 cities. And we started with a neighborhood that was ethnically diverse on purpose for that reason. And we went to Washington secondly, again, ethnically diverse in Washington, and then other populations in the other 3 cities. And we're going to expand and go from there. And then on top of that, we're building on, we're hoping to leverage the value of using advanced technology like this kind of creepy GAN thing I talked about earlier to further diversify the simulation data that we use to test and validate our data.
Okay, right here. Oh, here.
Hi. Well, this was totally fascinating. I'm somewhat of a Luddite, so all this stuff both I find weird, scary, and cool. My name is Karen Friedman. I'm actually a consumer advocate. I work on pension issues, and I work with a lot of truck drivers in the Midwest who already are having their pensions cut because there's not enough active workers paying into the pension funds. Can you talk a little bit about the impact on jobs? Because as I'm watching the horizon of all these self-driving cars, I'm also watching all these people who will no longer have jobs. Taxi cab drivers, now Lyft drivers, Uber drivers, truck drivers throughout the country. I'm sure you guys have thought about this, so I just want what do you think?
Yeah, well, thanks for the question, Karen. It's a very important question, and it's not the first time that an impressive technology has displaced a subset of workers in a particular discipline. The good news, and I don't know what this particular form is going to take, but the good news is history teaches us that every time that happens, the quality of the job that they move to and that they get retrained to actually repurpose to improves. And so I hope that this leads to the creation of new economies, like assisting the truck ecosystems to do more work and create more value, just as one example. You may not need as many truck drivers if you deploy autonomous truck solutions at scale, but you may need more workers working in the truck depots. You may need more people supporting the companies who are in the business of deploying these technologies to these companies that are integrating them into the trucks. I just kind of made those up, but I believe that there will be some form of a new economy created around the promise of new business models that come from having autonomous trucks and autonomous vehicles and autonomous package delivery services.
But Karen, to be fair, I had this discussion with Mark Andreessen. He's like, the farming to manufacturing was better for people because there were more jobs. The fact of the matter is there was enormous displacement and problems and social problems and fights and there's going to be a terrible toll on a certain group of people. There's no question. And anybody who tells you different is, and in terms of some of the truck stuff, they're not going to just have drivers, they're going to have robots loading these things. They're going to, if anyone's visited any of these, like an Amazon warehouse or anything, they're going robotic. They have this company called Kiva that's amazing. They have everyone's going robotic and automation in a way that I think is another big trend, and this is all governed by AI. It's really, it's a really interesting, it's fascinating, and in fact, workers probably shouldn't be putting stuff in boxes. Like that should be a robot. That's like it's a repetitive job, and it's more as it becomes more efficient. Same thing with like right now in San Francisco, we have burger flippers. Burger companies where you make a burger. It's just burger people that make burgers are cheaper than the robots right now, but eventually they won't be. That kind of thing. So it's going to have it's displacement, but the issue is, will they come up with new jobs? And
right.
Who does it? Who does that? And that's the problem, is we don't know. Is it Silicon Valley? Is it the government?
Right. And I think the broader issue is, what's going to happen to the sort of the middle class blue collar worker and over the long term. I don't have the answer for that, but I think it's a real issue.
Yeah. And years ago, I did an interview with Travis Kalanick when he still was CEO of Uber, before he left. And he actually was honest about it. And I said, what's the problem you face? And what is the thing you want to do? And he actually spoke the truth, which Silicon Valley people tend not to do sometimes. And he goes, well, you know, Kara, the real problem is the drivers. Once we get rid of them, it's a great business. But the drivers are the problem. Yeah. And like, he's an awful human being, but he was correct. He was telling the truth. He was saying is once we remove the drivers from the equation, the business becomes economically fantastic. And I was like, and I was sitting there going, thank you, thank you, thank you, thank you for saying that truthfully. And the whole room was like, all of Silicon Valley was like, don't tell them that. Like, don't say kind of thing. But that's really the truth, probably. Anyway, next question. Right where? Right there, and then right there. We'll answer just a few more because we got to get
Thanks so
going.
much for this conversation today. I wanted to revisit the issue of congestion. I think it's a really important issue. Anyone who lives in the city, whether you drive or not, you know it's an issue. New York
They just passed something today.
just approved, right, congestion pricing in Lower Manhattan. It's only gotten worse with Uber and Lyft, and has numerous issues on public residents, from public transportation taking longer, so it might take people longer to get to work if they use public transportation, to emergency vehicles taking longer to get to places they need to, and that's not even talking about pollution or climate change effects. So I wanted to know how you think about how you think about autonomous vehicles might address this problem. At least in the beginning, introduction of more vehicles on the roads, whether they're autonomous or not, seems like it could make this worse in the short term. So how do you think autonomous vehicles could help address this problem? And is there a way that autonomous vehicles could address this problem in a way that would take more vehicles off the road?
So I think the fact that the vehicles are autonomous in and of themselves will not make the problem better. I think autonomous vehicles deployed smartly into the city in a way that positions the autonomous vehicle after it drops off the person in a way that minimizes the additional movement. In other words, optimizes the routes so that it's not, a dumb autonomous vehicle in the sense of what ride it chooses to pick up. So it's not just the AI for the driving task. There's got to be AI in the routing task of which vehicles do I send where, and how do I reposition them when they're not busy moving people. That can reduce congestion, because if you didn't do that with an AI algorithm, you would be doing it, one ride at a time by human, with a human optimizing it based on their sort of social contract.
But Uber and Lyft have these maps. They've been mapping this kind of stuff for a while, correct?
They do, and I think those are examples of how their algorithms are actually helping their drivers optimize their system. But an autonomous vehicle, in a longer term scenario, could optimize across multiple fleets, and not just individual fleets if you could somehow figure out how to do a contract that way. But you have no hope of making it better if you don't think about the problem as an optimization problem and a routing problem.
And that's what you're doing with these scooters now, where they should be,
Exactly.
and where they should be put back once you've charged them.
Exactly right. And so the scooters are part of the solution as well, because you can offer a person a way to go somewhere without getting in a car if it's short enough. So that's part of the optimization solution too.
Or you can do what's happened at Austin, which they've dropped 400,000 scooters on a very small city, and it's insane.
Oh boy.
I love it.
Boy.
Where's the next one? And then two more. Right there, and then right. Oh, did you already ask a question? Did you?
Not me.
Did you ask me? Okay, go ahead. Go. I just don't. And then over here. Sorry.
Hi.
I can't see very well.
Hi, Trooper Sanders. So as you're thinking about deploying fleets, you have to think about maximizing revenue. What are your thoughts or plans on people who can't necessarily afford to pay for transport and dealing with the equity and access issues?
Yeah, that's a really important point. And so we're creating a living laboratory in downtown Detroit to help us figure out how to solve that problem. For those of you that don't know, we bought the Michigan Central Station, which had unfortunately have become sort of the iconic eyesore for the downfall of Detroit. But at one time, it was the grandest train station in the world, and so we bought that with the promise to revitalize it and bring it back to life and make it again the sort of centerpiece of the Detroit mobility ecosystem. And around the train station, we bought 4 other properties, and we're working with the city, and we're in the process now of talking to strategic partners to join us in sorting out that very problem. How do you solve the mobility problem in an inner city, in this case, in our own backyard, in our hometown, in a way that gives people transportation to the underserved, that revitalizes a community, that figures out how do you tap into the potential of making the street smart. So this idea I talked about earlier in terms of putting sensors in the road and making the city smart, well, we're going to start with experimenting in Corktown. And we might find a way to offer very affordable mobility to the underserved community there that we can then scale out to the world. But this isn't just altruism. This is part of a way for us to actually have a viable business as well. Because if you can democratize mobility, you can make a good business. Henry Ford proved that over 100 years ago.
Well, there's nothing wrong with altruism. Also, one of the issues is when you start, all this stuff is being done, let's underscore, by private companies, a lot of this new stuff, and it takes away from public transport. Like a lot of these innovations, like you should see the stuff they're doing in China. It's insane, around buses, around small cars, around rickshaws, and it's all private. And so once private, it's like private prisons, private anything, you're going to get a lot of problems. And so it'll take money away from public transportation things, as you know, which are so hard to, we can complain all we want about our subways, but they're miracles, like the way they work right now. And at the same time, they're not adequate. And so that's one of the problems, is they're all private companies going to be taking over transportation, and they sure aren't going to go where the money isn't. So that's one of the problems.
Yeah, well, one of the things that we're going to explore is how can you make these things coexist? Mm-hmm. And in the case of Detroit, there isn't a really healthy public transportation system, so we don't really have that issue. But if you think about taking a solution like the Corktown solution that we'll be developing over the next several years to a city that does have a healthy subway system, we would want to design the solutions so that it amplified that and it could coexist with it and make it better and solve some of the pain points. Because not everybody wants to take subway, but some people would. So I think that's in the category of work to do, but you got to start somewhere.
Yeah. I don't know if you noticed, Uber's trying to get into the subway systems to pay for subways with your Uber app stuff, which is great, but maybe not so much. You know what I mean? You start to think about it. Okay, last question. Whoever has it, right here.
How much data sharing is happening between companies, and if there's an incentive to kind of hoard this data to yourself, does that hold back the industry as a whole in terms of making it safer for consumers?
That's a good one. That's been controversial because
well, I mean, look, I'll just be transparent. I mean, there's basically no data sharing between the companies. Data's the new oil, right? We all have our oil wells, and
exactly right.
That's just the way it is, and that doesn't mean it's going to always be that way. At some point, this is going to get to the point where the technology itself is somewhat commoditized. The exception to the rule here is China, and you guys talked about this earlier on the prior discussion. In that case, the data is all state-owned, and so they've got an unfair advantage just because of the way the government works in China. And so I think there's going to be I think some pretty tough decisions and discussions that we're going to have over the course of the next, say, decade, as AI evolves and grows up and begins to be truly adopted and matures in some of these sectors, like the autonomous vehicle sector and smart home and digital assistants. But right now there's no data sharing. I mean, Amazon's not sharing their data pool with Google, and Ford's not sharing our data pool with GM, and I mean, nobody's sharing their data, which is why competitive collaborations are so tough.
Yeah. And then in China, the fact of the matter is the reason they're innovating so much is because they have the ability.
Because they have that.
They,
That's right.
The innovation going on there is amazing.
I just spent a week in China, and I came back. My head was about to explode. I mean, they're just going at light speed. So I think we got to learn how to go at that speed. So it's a powerful question.
Okay. Thank you so much, and thank you, everybody. Thank you.